Hello, so we're back, and this time we have a nice laptop to repair. Check here, Asus i5 9 Gen and NVIDIA graphics. Asus. So what's the problem with this laptop? Let's see what the customer is saying. The customer is a computer shop. Hi, sorry, laptop will not charge. Battery is 0% always. PSU supply and screws removed from the base. Thanks, John. Thank you, John, for sending me this laptop. Now let's test it, just to be sure about the fault. The problem is I don't have this power adapter. On my connectors, I don't have the Asus one. Now let's plug the customer charger. Plug in the charger, pressing the power button. Let's go BIOS. The laptop, it is coming on. So we're in BIOS and the battery is showing 0%. So what does it mean? Because we cannot read the current, we have no idea. That I'm trying to explain yesterday on the video with the tools. You have to see the current is taken by the laptop. Maybe the voltage is reported incorrectly by the battery. Maybe the battery is faulty. Maybe it's not charging. You see, there are so many variables here, and it's hard to figure out the fault. I'm plugging the charger, and the laptop is switching off. So you can say, okay, sorry, then the battery is faulty or the battery is not charging. Can be. Now, we don't have the screws here, so let's take out the back cover. So taking out the back cover, yeah, it's a nice motherboard. Check here. So what you will check? You have one fuse here, check. You see those white thingies? One fuse here, and you have one fuse of the battery, you can see. And you'll say, okay, sorry, let's check the battery. Okay, let's check the battery. Not sure how this can help us. I mean, we already figured out, actually, is no voltage into the battery. So checking with the multimeter, not sure how this can help us. So let's see, on the battery, we have 12.2. And here we have 11.7. Oh, Lord. 11.7. Well, it was 12. It was 12 volts. We've seen all 12 volts there. Now it's 11.7. So 11.7 on one side, 11.7 on the other side. Okay, let's plug the charger and let's see if it's charging. So on the battery, we have 12.4. 5051. It's not going up, right? 1 second, I'm confused. So I'm plugging the charger. The battery voltage is 12.2. But plugging the charger, the battery voltage is 12.4. Okay, the battery has 3 cells, yeah? 3 cells of lithium means 4.2 times 3. So this battery fully charged has to have 12.6. And the battery has 12.4. That means the battery is fully charged. I'm plugging the charger, and we have 12.3. It's not fully charged, but it's not discharged. So if we are pressing the power button, what will happen with the voltage? That's the question. So we have ground here. Let's see if we are pressing the power button. Yeah, we have the power button here. What it will happen with the voltage? Because she will start with 12 over 12 volts. So pressing the power button, and nothing happened. Huh? Why is not starting with 12.2? Huh? Okay, this is kind of a unique fault. I didn't see this fault before. The battery has voltage, but it's not starting. 1 second. What about the main power rail? The battery voltage is reaching the main power rail? We have 12.2 on the main power rail. Pressing the power button, nothing happened. Yeah, the voltage it is reaching the main power rail. But the EC chip doesn't want to read the power button. But the EC chip is on. 3.3. The EC chip is on, so the EC chip has 3.3. Okay, so the battery voltage is 12.2. Here are 3 lithium cells, means the battery fully charged has to have 12.6. So this battery is nearly fully charged. Now check here, plug in the charger, and the battery voltage slightly is going up. That means the charging circuit is fine. Now we have 12.4. Pressing the power button, and the laptop is coming on. Unplugging the charger, check there, 10.8 volts, 10.5. You can see? Yeah, and the laptop switch off. So basically we have no fault here apart from a very high resistance on the battery power rail. So from where this high resistance can come? Let's try to have a look at the connector. So on the connector, no. On the connector, the ground is ground, the plus, no, because we check the voltage here, yeah? So whatever is happening inside of the battery, not on the board. The ground, we have 2 pins to ground, as mean probably is connected to ground, so no point checking, and the plus, so we checked here, yeah, not after the fuse or after this current resistor. So clearly, is something wrong with the battery. Now, not sure how the analyzer can help us on this case, to connect the battery to the battery analyzer. I mean, the battery is not locked. It's just dodgy. I mean, 2 volts. I get like nearly 2 volts drop when I'm unplugging the charger. That means the cells cannot hold up the current. The cells or the power rails, yeah? You have plus and minus coming to the board, then it's coming from the board to the connector here. So somewhere we are losing voltage, right? No, we are losing current, yeah? So I will say the voltage is as a result from losing current. So let's try to open the battery and try to have a look inside of this battery. Yeah, we have the board here. Check here. Where is the fuse? Okay, the fuse is here. Check here. So that's the heated fuse. Obviously, is good because the battery it is working, but it's working like badly. Now, the proper way to test this battery, how we can test that? We can connect it to the laptop and try to check if same voltage dropped here compared with the voltage dropped on the cells, right? We can do that. Or we can come with the artificial load, yeah? So let me grab my big resistor and let's check together. So what do you think about this? This is a proper resistor. Let's see how much current is taking at 12.2 volts. 2 amps. So it's taking exactly 2 amps with 12.3 volts. Perfect. Perfect. Okay, we need a multimeter to monitorize the voltage. So this wire, it will be always there, right? Yeah. And this one is 0. Oh. Why is 0? Don't tell me the battery is not getting enabled. No, we have no voltage. That's crazy. We have no voltage because it's not plugged in onto the laptop. That sucks. Okay, that's fine. That's okay. Okay, let's check the cells. At least we can check something. So we have 12.2. So checking the cells, we are connecting the resistor here and here. So 12.2, and now we have 11.2. We are losing like 1 volt. Kind of high, 1 volt. It's not 2 volts, but even 1 volt, it's a lot. $11.2. And without, we have 12.2. We are losing 1 volt onto the cells. But it's still 1 volt. It's not like 2 volts. Okay, that's fine. That's fine. Now let's check the cells resistance. So every cell voltage has, we have 4 volts, we have 4 volts, and we have 4 volts. So all cells are equal. Now, trying to pull out some current. Good. And now the voltage is 11.2, but the first cell has 3.5, 3.5, 3.5. This is a very used battery. Oh lol, it's getting mad hot. So basically you don't need a device to figure it out. Actually your battery is kind of used, like this one. We are losing like what, 0.5 volts per cell with 2 amps. Yeah. I mean, here is not about the electronic board. We check each cell individually. Just for our information, yeah? Let's connect the NLBA to this battery and let's see how many cycles are there and what is the reason this battery is actually so used. I mean, it's so used and it's still working. It's not locked. This is surprising me. I mean, this battery should be locked. Okay, so we have the software on the screen. Yeah, like that. Good. And press start reading. Yeah, start reading. And we are looking for clock and data. Very simple. Has to be here somewhere. No here. No here. Let's spin the wires. No here. Here. Ha ha. I found it. I found it. So this battery cycle count is 197, 187. Check that. 187. And why is saying the battery is locked? Because we don't have the enable pin? Yeah, probably. We need a ground somewhere, probably here. Yeah, okay. And now the battery is unlocked. Have in mind this, yeah? You need, you have 2 ground wires, the first wires. And then you have the next pin. Those are together. First 2 are together is ground. Then the next one has to be connected to ground. And you can see now the same battery is unlocked. So that's the enable pin onto the battery. So the battery is unlocked, the cells are balanced, and the cycle count is 187. Now I'm curious about the capacity, but read capacity has no capacity. So this battery is empty. Health, nothing. I mean, nothing. No capacity and no health. So how this battery is working? Why this battery is not locked? Let's try to charge it. Start charging. And it's taking current. Check here. It's taking current. And now the current stopped because the battery is nearly fully charged. Yeah, it's taking only 300 milliamps. Let me make this window bigger just to see the state of this battery. Start discharging. Check on the voltage. The voltage is crashing. I mean, it's like 3.8 volts right now. Look, 3.7 volts on the cells, and the battery it is providing like 2 amps, but the cell voltage is like 3.7 volts. But it is providing 2 amps. You can see the current here. Yeah, 3.6 volts. So basically, the cells are discharged already. This is unique. I never seen a battery that used. Yeah, so the cells are 3.6. Stop charging. Let's go to test. No. Cell check. Read battery configuration. Here we have 3 cells. The battery is supported. The battery does not allow discharging. No, we can't test it because we cannot reach 30%. Because obviously, as soon as the devices start checking the cells, the voltage drop. That's how the device is checking the cells, if the internal resistance of the cells. But if I start like pulling 2 amps, the cell voltage is just getting dropped to discharge. Oh yeah, actually the program is telling us. So fully charged capacity is 0. You know, I missed this. I missed it. So basically, this battery has no capacity left. And the initial capacity was 3.5 amps. You can see here, design capacity. Yeah. But the actually capacity of the battery is 0. Remaining capacity is 0. And only 187 cycle count. Yeah, okay, it's clear. It's nothing what we can do. It's just this battery is like after 187 cycles, it's just, dead. So why we lost so much time with this? First of all, this is kind of unique case. So this battery is 0 capacity, but it's not locked, and that's not normal. Because usually a battery is locked, can quickly check with the analyzer if indeed the battery cannot be fixed and order another battery. But this one, it was a weird one. So sadly, is nothing what we can do for this battery. Nothing. The battery is just very, very used. But hopefully you understand how you can check actually the battery health without a software. Yeah. So that's what I want from you to have in mind from this video. Very simple. With a resistor, you can check the voltage drop on the cells. The more voltage is dropping when you are coming with like 2 amps, yeah, like this resistor, it's set up to draw like 2 amps. So the more voltage is dropping, the more used are the cells. Because I'm pretty sure not everyone has the analyzer. We did figure it out before the device, actually the cells are used. And that's what I want from you to keep in mind from this video. So I'm gonna stop now. I will advise the customer to buy a new battery, or maybe I can order a new battery. Yeah, I can do it. Yeah, I can order a new battery. I will say thank you for watching. Just like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.